Hi everyone. So this video is the first video in the surds and other radicals unit. So this first video will be just getting sort of familiar with some vocabulary words and learning a few key pieces about how radicals work. So first off, a radical is a number written using the radical sign. So we see this radical sign written here. So any number written using that is referred to as a radical. Those numbers are often written using the radical sign because if you were to solve that out and actually take the square root of that number, for example, you would end up with a very long decimal, an irrational number. So oftentimes for precision's sake, we'll keep the number underneath the radical sign rather than take that to a decimal. So you are used to, I think, seeing those numbers when we're talking about square roots. So if you take the square root of a, for example, that is the non-negative number, which when squared gives us a. So if you have the square root of a times the square root of a, that gives you a. And we can test that out with an example that we know. So for example, the square root of 9 times the square root of 9. Well, we know that the square root of 9 is 3, so we can do 3 times 3, and we see that that in fact gives us 9. So the square root of anything times the square root of that same thing is going to give you the number that was underneath the square root sign. You can only take the square root of a number that is positive. So real number only if a is greater than or equal to 0. So I said positive number, but 0 also you can take the square root of. So then by extension, we have this idea of cube roots of a number. So if you have the cube root of a number and you cube that, multiply it by itself 3 times, you will get the number underneath the root sign again. So we could test that with something that we know. So we could take the cube root of 8 times the cube root of 8 times the cube root of 8. And we know that the cube root of 8 is 2 times 2 times 2, and that in fact gives us 8, the number that was underneath the cube root sign in the first place. Now, interestingly, with cube roots, if the number that is underneath the cube root sign, the radical sign, is positive, then our answer will be positive. So if we take the cube root of positive 8, we get positive 2. If we take the cube root of negative 8, we can do that unlike with square roots, and you would get negative 2. Because if you think about it, negative 2 times negative 2 times negative 2, that is how you end up with that negative 8. And then you can extend beyond square roots and cube roots to any number. So we have the nth root of a number. And if you take the nth root of a number to the power of n, you get what you had underneath the root sign. So same idea as if you have a square root of a value and you square it, you get the number that was underneath the radical sign. If you have the cube root of a number and you cube it, you get the number that was underneath the root sign. So that's all fine and good. A little bit of background to kind of get us in the right headspace to take on some of these questions. So if we look at these two examples, we're asked to simplify root 2 to the power of 3. So that means we're multiplying root 2 times root 2 times root 2. And we just learned that if we have a root multiplying by itself, a square root multiplying by itself, that gives us the number that was underneath the square root sign when we started. Then we have this extra square root of 2 here, so that will get tacked on together. So I need you to think about this like algebra. So if we had 2a, for example, there is an unwritten multiplication sign in between those, but we learned when we learned how to write algebra that we don't write that multiplication sign. It is exactly the same with radicals. There is an unwritten multiplication sign in the middle there. We don't write it, so we would just write 2 root 2, and we would say it that way, 2 root 2. Okay, moving on to second example here, we have 4 over root 2, and that is squared. So we have 4 over root 2 times 4 over root 2. So we multiply fractions by going straight across the top and straight across the bottom. So straight across the top is 4 times 4, which gives me 16. Straight across the bottom is root 2 times itself, which gives me the number that was underneath the square root sign. And then we look to simplify that. We know that that fraction bar indicates that that will be a division. So 16 divided by 2 gives us a final answer on this one of 8. And then we had 2 root 2 on the first one. Okay, so new vocabulary word for you probably is surd. So surd is a very specific radical that is irrational, meaning if you were to take that square root on a calculator, you would get an irrational number. So the examples that are listed here, root 2, root 3, root 5, if you actually did those out on your calculator, you would get decimals that are unending, irrational numbers. So those are very specifically referred to as surds. And then we see that the square root of 4 is not a surd because if you actually solved it, you don't get an irrational number, you get 2, a whole number. Whole numbers are not irrational. If you take the square root of 1/9, that is also not a surd because when you take the square root of 1/9, you get 1/3. So if you were to take the square root of a number and get a ridiculous decimal, irrational number, that is a surd. If you take the square root of a perfect square, for example, like 1/9 or 4, those are whole number answers, or at least not irrational number answers. So then those would not be considered surds. So because we're dealing with values that if we were to take the square root of them, we would get a ridiculous decimal, we don't want to do that because the second you have to round that number, it is less precise than keeping it under the square root. So over the course of this unit, we're going to learn about a whole series of ways to deal with these kinds of numbers without having to work them out as a decimal on the calculator. All right, so first example we have here, 3 root 2 squared. So again, that means 3 root 2 times 3 root 2. So if you think about algebraic ways of doing this, if you had 3a times 3a, we would multiply numbers by numbers and letters by letters, and we would get 3 times 3 to give us 9. A times a gives us a squared. So numbers get multiplied by the numbers, letters get multiplied by the letters. It is exactly the same when we're talking about radicals and surds. We're going to multiply the numbers by the numbers, so in this case 3 times 3 gives us 9. Then we multiply the roots by the roots. So root 2 times root 2 times itself gives us just 2. So this becomes 9 times 2 to give us a final answer on this one of 18. Second one here, we have 3 root 3 times negative 2 root 3. So again, coefficients by coefficients. So 3 times negative 2 gives us negative 6. And then roots by roots. So the root 3 times the root 3 to give us just 3. And then negative 6 times 3 gives us negative 18. Okay, so that's a basic introduction here on radicals and this idea that when you multiply a radical by itself, a square root by itself, you get the number that was underneath. When you multiply a cube root by itself 3 times, you get the number that was underneath. And then we looked at a couple of examples of applying that to some different situations. So that's it for this video.